Okay, welcome back everybody. What we're going to do today is look at our first basic trig ratio. Now the first one that we'll look at is called the sine ratio. Now what I'll do is I'll write down the ratio for you and we'll actually examine it together first. So this is the sine ratio. Sine angle theta is equal to opposite side over the hypotenuse side. So what this means is this is a ratio that will work for every right angle triangle. So provided we have that right angle triangle, we've got our calculator as well. We will need a calculator for this topic. Any right angle triangle, if we've got the same reference angle, the opposite side divided by the hypotenuse side will always be the same value, which is really, really handy. Now, another way that we can write this for short, you'll often see it written like this, just S-I-N, sin or sine. And instead of writing opposite, we can write O over H. So I'll try and show you what I mean by this by looking at a diagram. I'll just find it. Look at all these windows that are open. Just one moment. There it is. All right, let's have a look at these triangles here. You'll notice that all of the angles here are the same. They're all 37 degrees, and we've obviously got our right angle as well. Now, if I have a look at the opposite side, remember from our labelling that opposite means opposite the reference angle. So this is opposite, this one's opposite, and that one's opposite. And obviously this one's opposite the right angle. We know that's the hypotenuse. What I'm going to do is have a look at the value of O over H for each of these. So the opposite side over the hypotenuse side for each of these triangles. So for this one here, we have 6 over 10. This one here, we have 3 over 5. And this one here, we have, 9 over 15. Are these equal? Yes, they are. They're all the same. 6 over 10, 0.6. And if you look at 3 over 5 as well, you'd know that's 0.6. And also 9 over 15 as well, again, 0.6. So actually, if we look at this, same angle each time, the ratio of opposite side to hypotenuse side is the same. This is going to help us solve these unknown lengths in the right angle triangles. Okay, so let's have a look at some examples. Perhaps before we do that though, you might like to put a title in your summary book, the sine ratio. Write this down for me, this screen here. Pause it to give you some more time and then we'll do some examples. That's one of them. Here we go. This is the one I was looking for. Okay. So this is a typical trig problem. Have a look. Right angle triangle, reference angle given, 26 degrees. I've got an unknown side here. It's given x. It's the variable. We've also got one side that is given, and that's 8 centimetres. My first step when solving trigonometry problems is to label the triangles. So I've got here this angle. I'm going to look opposite that. That must be the opposite side. And this one, longer side, hypotenuse. As you can see, I've got the opposite side. I've got the hypotenuse. So immediately, I should be thinking of this ratio. Now, because this is the first one we've looked at, obviously this is the one that we're going to use today. But you don't know what ratio you're using until you label your sides. So this is the ratio I've got. What I can do now is actually substitute in the values that I know. Remember, this here is the angle. So what I can do is go, all right, well, sine, oh, definitely not 36. It is 26. Is equal to opposite side. I don't know what that is. That's given as x. Hypotenuse side is 8. Now, what I've got is this here, I can actually put in my calculator and it will tell me what that ratio is. Because like I said, for any reference angle, the ratio of O over H will be the same, and your calculator knows what that ratio should be. So if we can type in sine 26 into the calculator, we'll actually get what this fraction here with this ratio should be equal to. So what this means is I can actually rearrange this so that I've got x equals. I've got x as the subject. What do? I'd have to multiply both sides by 8. Therefore, x is equal to sine 26 times by 8. Now, if you look at your calculator, there it is there, you'll see this button here, sin. So what you'll do is you'll type sin 26 and then enter, and you will get your answer for sine, but of course we wanted to multiply it by 8. So you'll do that as well. Now I did that on my calculator and I got 3.51 rounded to 2 decimal places. And remember, we've got a unit here, centimetres. So there is my answer. That is a typical trig problem using the sine ratio. Pause here and put this example into your summary notes. Okay, here's a second example. This one you'll find is a little bit different. Again, first step, label the sides of your right angle triangle. So, opposite the right angle, that's my hypotenuse, opposite the reference angle, the 44 degrees which is given, is my opposite side. Again, I'm working with O and H, and we know that the sine ratio links those beautifully, doesn't it? Here we go. Again, we're going to substitute. My angle is 44, opposite side is 12, and my hypotenuse this time is the one I don't know. Let's just zoom down a little bit so we've got a bit more space. Now this one isn't the same because this time the x is on the bottom. To solve this one, what I'm going to do is 2 steps really. First I'll multiply both sides by x. Is equal to 12. Obviously when you multiply this side by x, they cancel out, don't they? Finally, to get x, I can divide both sides by sine 44. This you can do in your calculator. Again, looking back at the calculator screen here, you would type in your 12 divided by sine 44 and press enter. I'll do that on my calculator now. Remember to round appropriately. What I've got here is 17 point, well, hopefully you can see that, 17.27. Now, did we have a unit? We did. It was centimetres. Make sure you include that as well. So 17.27 centimetres. Pause here to get the diagram into your book. I'll zoom down as well. You can pause here and you can get all of the workings into your book as well. It's best to get a lot of practice with these because as you can see, they're not all the same. It does require substituting values into the rule, into the ratio, and then solving for x.